Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of exam practice with the Batty Boffin and Batilda the Batty Cat, our mascot for all these exam questions. Now this one is aimed at higher level GCSE or whatever the equivalent is in your country, and today we're going to be looking at pyramids question. Now Batilda has been on holiday to Egypt, and being a cat she has managed to sneak in and run up this pyramid. It's a slightly unusual one. Firstly, it's made of glass so you can see straight through it, and secondly the apex is not over the centre. Now it has the dimensions as given on here, and I'd like to know please for part A, what is the distance AC? Off you go with that, and I'll see you in a minute to go through it with you. Right, the first thing to do is to put on some dimensions. We're given AB, which is this one here, and AD are both 6. We have CB is 4, and CD is 5. The base is a rectangle of 5 and 6, so a simple bit of Pythagoras will find us the diagonal. So we're going to do an A squared plus B squared equals C squared, or as I usually put it, short squared plus short squared equals long squared. Obviously the sides aren't labelled A, B and C, and this one here, that's just standard Pythagoras. Short squared, we have 5 squared plus 6 squared equals the thing we want squared. I'll mark that on here. There it is. That's our question mark side. Okay, so that gives us a 25, that gives us a 36. That comes, I believe, to 61. So that means that question mark is the square root of 61. We'll stick that in on the calculator. Let's just see what we get. Square root of 61 is 7.81. Equals 7.81. Okay, 7.81. So that's part A. Now for part B, I'd like to know, please, the angle at the top of the triangle, angle ABC. So for part B, find the angle ABC, and I'll come back and do that with you in a minute. Right, I've drawn out the triangle ABC. AC that we worked out is root 61, and I'm leaving it as that rather than the thing with to do decimal places because that's more accurate. We have this side 6 and this side 4, and we need the angle at the top. Okay, so when we're doing things like this and we haven't got right angles, we can't be using Pythagoras and Trig, so we're going to be using sine rules and cosine rules. Currently we haven't got any angles in there at all, so we can't use the sine rule, so it's going to be the cosine rule. Okay, now if you didn't twig how to do this and you've now gone, oh yeah, cosine rule, of course, I'm just going to jot it down for you, then I'll let you have another go. Standard way of writing the cosine rule is A squared equals B squared plus C squared minus 2BC cos A. Okay, that's the way you usually find it in the formula books and things like that. You may wish to relabel things because we're not wanting angle A, we're wanting the angle at B. So I'll leave you with that, and I'll come back and work through it in a minute. Right, because we're wanting the angle at B, I'm actually going to rewrite this slightly. Instead of having a cos A at the end, I'm going to have a cos B at the end, which means I've got to have a B squared over there equals A squared plus C squared minus 2AC cos B. Okay, whatever that one is, that one's the same, and these are the other two. Okay, so I'm going to use that version of the formula, and I'm going to rearrange it so that it says cos B equals. Okay, so first thing I'm going to do, oh hang on, that should be a minus in there, not another equals. First thing I'm going to do is add this to both sides, and then I'm going to subtract B squared from both sides. I'll do that all in one thing so that I don't run out of room on here. So I'm going to add that to both sides. Okay, subtracted b squared from both sides, and now we can divide both sides by 2ac. Okay, so there's my formula. Now I'm just going to substitute in the values that I've got up there, and hopefully the answer should just pop out. Happy with that substituting in? For the value of b, here, labelling up the triangle in the standard way, I've used root 61 squared. So of course when I square that, that'll just be 61. So 16 plus 36, take away 61, equals that there negative number divided by 48 gives us a negative answer for the cosine of it, and then we're going to inverse cosine. It should be the thing that looks something like that, or it might be marked arc cos or inverse cos, depending on your calculator. Cos to the minus 1, arc cos, or inverse cos, whatever it is. I'm going to do, it's the shift button gets cos to the minus 1 of the answer equals, and we get an answer for b of 100 to 2 decimal places 0.81 degrees. Okay, larger than 90. That's how come we had a negative number up here for the cosine. Okay, so 100.81 degrees. Hope you're okay with that. Okay, the final part, part C, Batilda would like to know how far above the ground she is. So it's what you'd normally call h, the vertical height of this pyramid. Okay, see you with that in a minute. Right, I've marked in the vertical of this triangle here that we're going to find, and as you can see it splits it nicely into two right angled triangles. So we could do our nice normal trig on this by finding this is the opposite of this triangle here, but we would need that angle and we haven't got it. Similarly, we could do it by using the opposite of this right angled triangle here, but again we don't have the angle. We've got the angle at the top, but that's not a lot of use. I hope you didn't even think of splitting that angle in half and splitting the bottom side in half. That's fine if it's an isosceles triangle, but that is not isosceles, so those two bits are not the same. We're going to have to use the sine rule on this to find either the angle at A or C, it doesn't matter which. Sine rule is normally given like this. Now we're trying to find an angle, which is one of these unknowns on the bottom, and it's a bit awkward having the unknown on the bottom, so you can actually use the sine rule entirely upside down, like this. Okay, either way up. We're going to use it this way up. Given that we've got an angle at B, we'll use that bit, and we can use either A or C, it really doesn't matter. I'm going to use A. So we're going to use that version of the sine rule today. So sine A is the thing we want, over A, which is 4, equals the sine of 100.81 over B, which is root 61. Okay, what we're going to do here to rearrange that to make it equal sine A is we're going to multiply both sides by 4. There we go. On your calculator to put that in, please make sure you don't do the sine of 100.81 times 4, as in the sine of kind of 400 and something degrees. Please, sine of that, get the answer, divided by the square root of 61, get the answer, and then multiply it by 4. Okay, don't make that 4 link in with the square root or anything else on there. So the answer should be, I am going to do the sine of 100.81 is that, divided by the square root of 61 is that, multiplied by 4 is that. Okay, that gives me the sine of A, and then I'm going to unsign it, so shift sine of the answer, and we get an answer of 30.20 degrees. Okay, that's not the answer, that's this angle. To find here, this one here, the height, we're going to use standard trig. And I'm kind of assuming that by the time you've got to higher level, you're okay with normal trig, your SOHCAHTOA kind of stuff. Okay, we've got the angle, we've got the opposite is what we're wanting and the hypotenuse is what we want, so we're going to use sine on this one. So the sine of the angle is equal to the opposite, which is the thing we want, over the hypotenuse, which is 6. So keeping my angle in there, I'm going to do the sine of my angle, okay, and I'm going to multiply that by 6, and that will give me my length, my height there. So the height is 3, well, to 2 decimal places, 3.02 cubits, or whatever they were. So 3.02. Now we've done a lot in this one. This has got trigonometry, it's got sine rule, it's got cosine rule, it's got Pythagoras, all kinds of bits and bobs, and quite a bit of rearranging in there as well. So I hope you got that one there. If you got that, pat yourself on the head, take a gold star and a chocolate biscuit, and I will see you for some more exam practice in another video. Bye for now, Batty fans.